Hello, everyone. This is Keith Jackson, and welcome to Jack's Math Notebook. In this video, we're going to learn a little bit about probability as it relates to independent events and dependent events. As it relates to independent events, let's say we had a hat full of 20 cards, right? There were 20 cards in the hat, and there were four elephant cards, two zebra cards, six lion cards, and eight bear cards. And so let's say we wanted to select an elephant card. Well, your chances of selecting an elephant card out of the 20 cards available would be 4 out of 20. This simplifies to 1/5, meaning that you have a 1 in 5 chance of selecting an elephant card. But now that you put the card back into the hat, the probability remains the same because you're back to where you started from with the original 20 cards. And so if you put the card back, guess what? Your chances of selecting an elephant card would again be 4 out of 20 or 1/5. And the same is true for selecting a lion card. So if you wanted to select a lion card, your chances of doing that is a little bit higher than the elephant that you see right here, because there are 6 out of 20, right? 6 chances out of 20 to select a lion card, which simplifies to 3 out of 10. And so now with that in mind, if you put that card back, well, it becomes an independent event again because you're back with 20 cards and your probability of selecting a lion card will be 6/20ths or 3/10ths. But dependent probability is a little bit different. So let's say we had that same hat with those 20 cards in it. And again, we had four elephant cards, two zebra cards, six lion cards, and eight bear cards. But let's say we wanted to select that elephant card for the first time. And so now that probability, of course, remains at 4 out of 20 or 1/5. But what if we left that card off to the side? We just left it on the table. Now, guess what? We only had 19 cards, and we had three chances out of 19 to select that elephant card, provided that we selected an elephant card the first time, you see. And so our probability is now affected on the second chance or on the second try because now we're only dealing with 19 cards and we only had three chances to select that elephant card. And this would mean selection without replacement. And the same is true for any card that you select out of the hat. And so let's use lion again. And so let's say if you wanted to select a lion card, you have 6 out of 20, which equals to 3/10ths. But if you left that card out of the deck or out of the hat, you left it off to the side on the table, where your chances of selecting a lion card would become 5 out of 19 because, see, your first selection affected the probability of the second selection because you didn't put the card back. So let's take a look at the bear cards and the zebra cards to help us strengthen our understanding of this concept. So with replacement, if you put the bear card back into the hat, well, your probability of selecting a bear card will be 8 out of 20th or 2 out of 5 tries. But without replacement, without putting that card back, leaving it on the table instead of putting it back in the hat, well, your probability will go to 7/19ths. And let's take a look at the zebra card, for example. Probability of selecting a zebra card on the first try would be 1 out of 10 or 2 out of 20 tries. But if you didn't put the card back into the hat, well, your probability becomes 1 out of 19. Okay, yeah, I received a lot of information, and I wouldn't blame you if you need to pause the video if you need to gain a deeper understanding of this concept, or replay this video as many times as you need to deepen your understanding of what probability is as far as independent events and dependent events go. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. And remember this, whenever you're learning, you're always on the right track. Thank you and goodbye.